how did the worksheet go? Did you get some time to work on it a bit? No, it's pretty straightforward and it's intended to be. We don't want to, force people to learn all kinds of crazy things just so we can do a project. But for this next project, you do need to know a few things about hydraulics in particular. So do you have any questions at all about that? All right, well, go ahead and get that completed. And we will start on our next project here. I'm trying to find the right one. Hold on a second. Which is obviously going to have to do with hydraulics. I mean, we're getting very close here to the end of these projects. I think after the hydraulics, we're going to, let me just check the syllabus really quick too. Okay, let's syllabus. Okay, so yes, hydraulic arm project. We did our radio receiver and transmitter. Now, I didn't have a chance to look at your radio receiver because I'm still a little behind on my grading. I'm catching up slowly, but how did your radio receiver go? Were you able to pick up a radio station with it? Good. So you found the right diode and everything? Good. Great. And then how about the transmitter? Were you ever able to make that work? Uh-huh. Yep. Uh-huh. Uh-huh. So you were able to create static and receive static. That's not so bad. Probably one of the things that you have a problem with when you're transmitting, when you're trying to transmit, is matching impedances. And cell phones and iPods and other things have different impedances even from one to the next, and so they don't always work out with the electronics that we're using here. Ow. Okay, so anyway, I just pulled a muscle in my rib cage. But anyway, so if you were able to make it transmit something, some kind of static, and find that station, then that is, I would call that success. It would take a little bit more time and troubleshooting to probably make it all work out properly. But the whole purpose of that project was not necessarily to understand the electronics. It was actually to learn to follow instructions even when you don't understand something. And most of the projects that we've done so far have been a little easier to understand the basics, at least. Whereas, the radio, there's a lot of little black boxes in the radio, a lot of little pieces that you put into it, and you're not really sure why they're in there. But if you put them in there properly, you should be able to get something to happen. And so that is the idea behind that. And that is kind of how it will be graded. I'm grading for your ability to follow instructions and to make it work and everything else. So today, being Monday the 24th, We are into the hydraulic arm project, and sorry. If you'll notice on the syllabus here, we have these different parts of the design process: define, identify, search, feasibility, prelim, detailed, construct, verify. Those are all things from your textbook. The first one that we did is we did a little bit of defining, a little bit of pre-project work as we studied the science behind hydraulics. So that's what we started on Friday, and today we're going to define our problem and start the engineering process that we've been doing all along, where we define the problem, start to look at different options, different design options, create 3 possible ways to build this thing, evaluate those things, and then start to actually do a final design and testing and everything else. We have Monday, today, Wednesday, Friday, next Monday, next Wednesday scheduled to work on this project now. And excuse me. I think that it will be sufficient time to do so. So let's take a look at, we do have some some of the kind of a workbook similar to what we've used before by the same company, Teacher Geek. And this one here, this workbook here, is almost, it's more like an instruction book. And I'm going to provide it for you, even though I haven't provided you all of the parts that they're using here. Because this one is an instruction booklet for how to build this hydraulic arm that they want you to build. And I don't necessarily want you to build what they've built. I want you to build something similar, something that will do the same kinds of things, but not the same exact arm. And you can see here that they've built this arm, this hydraulic arm that has at least 3 or 4 hydraulic controls on it. And it can rotate and it can go up and down, and the arm can articulate so it can reach outward. And it also has a closing kind of hand here at the end. And it's using a lot of plastic parts that I have not provided. And it's using a lot of hydraulics. Maybe I don't know how many hydraulics I've provided, but it is using a lot of hydraulics. But the point is that it provides pretty much a just do it manual, how to do this manual. That's not what we want to do. And then I've got this other one that is a little more simplified. They give you instructions on how to build one of these things, a little more simplified. And they do a lot more, they talk a lot more about how these cylinders are going to act in the project, and how we're going to use these syringes to do things. But again, it's a little bit more about, instructions. We're going to show you how to do this, and then you build it. Again, that's not what I want you to do. I'm going to provide you with both of these so that it gives you some ideas on how to do this. And there are some activities in here that you can go through and use to your advantage if you'd like. I'm not going to force you to do that. They have some activities about mechanical advantage, how to use different size cylinders to make different forces, distance for, you're trading distance for force here. Actually, I might have you do some of these activities in this one. There's just a lot of stuff in here, and some of the things in this second workbook are going to duplicate what you just did over the weekend. So I don't want you to do everything. In fact, I'm not going to require you to do anything, but there are some activities in here that might be useful. So I would definitely recommend that you at least look through them and learn as much as you can about what you might do with hydraulics. But in the end, what I want you to do is use these workbooks to get some ideas and put together three different alternative ideas or alternative designs for a hydraulic arm, and then choose from among them the best idea that will fit the criteria, which we'll talk about here in a minute, and go through the design process that we've done before, putting together, while you're putting together designs, also putting together a logbook, an engineering logbook. We're going to do that again and again and again. This is extremely important. So you can also use ideas from online if you want to go online and find ideas, or from other textbooks or whatever else. I don't care what resources you use for your ideas for building this hydraulic arm. But I'm going to provide you with these workbooks that will allow you to get some ideas from them. So let's talk about the hydraulic arm and what we want from it, what we want to do with this hydraulic arm. I want you to build a hydraulic arm that will start off in one position, in height, in direction, and in reach. And I want it to be able to change its direction. In other words, I want it to be able to rotate. I want it to be able to articulate or move outward. So extend. I want it to be able to rotate at least 60 degrees, but probably 90 degrees would be better if you really want it to work well. So I want it to be able to rotate a fair amount. I want it to be able to extend from the base of your rotation platform, which we'll have to have for this thing to rotate, out at least 6 inches. And I want it to be able to move up and down from the floor to something at least 12 inches high, so a foot off the ground. So the criteria, once again, I want you to be able to move this thing in 3 different dimensions: rotation of 90 degrees, an extension from the base out 6 inches, and I want it to be able to move up and down at the end of the arm at least 12 inches. The objective is that we will put a tennis ball somewhere in front of your device, but it may not be directly in front of your device. And you should be able to go and retrieve that tennis ball and put it somewhere else. Ideally, I'd like you to be able to put it at the base of your platform. So, do you have any questions for me concerning this hydraulic arm? It's merely a test of your hydraulic device. I don't have any particular purpose, but this is not necessarily to fulfill a need. Although if I wanted to fulfill a need, I suppose I could. Let's see, what could I say for this need? We could always say that let's say that we're building a robot that can find tennis balls within a foot height and 6 inches of its front and 90 degrees from its arm. And you're designing the arm that's going to pick up the tennis balls when the robot finds the tennis ball. How's that sound? This is actually not an unheard of thing. The Mars rover had an arm similar to this on it that was designed to pick up rocks so that they could use them for testing. So the Mars rover was able to find the rock within a certain distance, or was able to get within a certain distance of the rock, and they built this articulating hydraulic arm that would go out and pick up the rock and put it inside of the testing chamber. So it's not entirely totally out of the realm of possibilities for a design project. But our rock, quote unquote, will be a tennis ball, and the other criteria are as given. Any other questions? Absolutely. If it takes you, less than 5 times to pick up the tennis ball, I would consider that a success. It would be, by next Monday you really should be testing it. By next Wednesday it should be completely done and successful. So next Monday you should, by next Monday you should at least have it built and be testing it. As far as research or as far as materials? Okay, so the materials that you use, I would like you to use the materials that are in your kit. And the only material that you might be short of would be hose. I've included, I think I included 2 rolls of 3 feet of hose. And if you need more of that and you can't find it at your school or nearby, tell me right away and I will send you some more of that clear fluid hose. Otherwise, the only thing outside of the kit that you can use would be a fluid to actually run the hydraulics. So you can choose a fluid. You can choose water or oil or alcohol or whatever else you want to choose to actually be your hydraulic fluid. Any other questions? Okay. For those of you who will watch this later, if you have any questions, please email me, and I will answer your questions and help you out with this project. Do remember to keep your logbook each time you work on the project, from research all the way through to testing. And I would like to see today is Monday, by Wednesday or Friday at the very latest, I would like to see 3 completed designs. And if you're going to have them to me by Friday, I would also like those to be evaluated for the best design. So 3 completed designs by Wednesday or Friday, and by Friday, I would like those designs to be evaluated so that you have chosen your best design. And that gives you some time to prototype that design, troubleshoot that design, and test that design by the next Monday and Wednesday. All right? If there are no more questions about either the worksheet, the hydraulic worksheet, or the hydraulic arm project, I'm going to go ahead and turn you loose to get started. We will meet on Wednesday in case you have any questions concerning your designs. So your initial designs, if you have any questions on them, I can answer them Wednesday. And then you can finish those up and have them ready for me. And then on Friday, we will meet together to talk about evaluating your designs, if you need any help with that, and if you have any more questions for the project as a whole. And of course, if you have any other questions for the project, please feel free to contact me. I am still planning on doing the drone project I will purchase and I will order the drone parts, the motors and the computer parts for the drones, the control parts for the drones, and then controllers as well. I think the only thing about the drone project that I'm going to have to require that some of those parts be sent back to me because they're so expensive. I'm looking for a drone that can be controlled by Bluetooth and by using cell phones. So far I haven't found one that is good enough. If I find one of those, I will let you just keep the parts. Otherwise, what I've got going so far is these drone kits cost $200 for all the parts and the controller, and that's getting really quite pricey. So if I can find a drone kit that is Bluetooth controlled, I'm going to assume that you have a phone or a device that is Bluetooth enabled so that you can control it. The downside to that is that Bluetooth only has a range of about 30 meters at best, and usually much less than that. So your drone will only be able to be operated, probably within a normal-sized classroom or maybe a gymnasium, a small gymnasium. Outside, you'll quickly lose control of it if you fly it too much outside. So that's the only downside to that end of it. But it would allow you to keep the drone parts and use it as much as you want later. So I will continue to look for those a little bit today and a little bit tomorrow, and try to get those ordered by the latest Wednesday or Friday this week so that they're ready when we start our new project a week from Friday. And that's all I have for you today, unless you have any other questions or concerns for me. All right, well, jump into the hydraulic arm project. This is by far the most complex project we've done so far. So make sure you get started early. Don't put it off. It will have a lot more moving parts and therefore a lot more things to troubleshoot. And we will see you Wednesday.